Virtual machines. Who's familiar with, who's deployed a virtual machine in Azure before? Okay, about half of you. Cool. So you'll be familiar with this screen. This is basically the marketplace gallery. Pretty much that's on the right hand side. That's the easiest way of deploying a machine. You know, you can see straight away. You want a Windows server, a Linux server. Click on that. You go through a series of sort of parameters. Tell it what size you want, and next, 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 and you know, within 15 minutes or so, you've got a machine. Sometimes faster. But there's other ways of deploying VMs. You've got a management portal, of course. You can do it via PowerShell, or any, you know, whatever type of scripting you prefer, if it's Bash or Linux. And then you've got the REST APIs, which, you know, for developing purposes, there's multiple ways in which you can deploy. But yeah, straight out of the box, you go to the portal, you can hit the marketplace, and you've got all these sort of images available. If you wanted to deploy a SQL server, you don't have to just go in and deploy a Windows server and then install SQL on it. You can just click, hey, I want a Microsoft SQL server, and it will do, you know, it's an image that already has SQL installed, and then you go there into SQL and provision your own database. Yes. So in the operating system itself, you have the Microsoft Windows Update service. Right, if you run it, yeah. But yeah, if you, what happened? If you don't run that, then it's a virtual machine, so it's your responsibility for keeping it patched. If it's platform as a service, then you know Microsoft are going to do that for you. But you're responsible for your operating system if you provision a virtual machine, right? That's infrastructure as a service. So generally speaking, yes, you would. You don't have to have it automatically install the patches. You can configure it to say, check for them, tell me what's available, you know, every week or whatever, and you choose to install them. But yeah, I would recommend for security purposes you do that. But of course, you know, this is operating within the data center, right? So you've still got that sort of boundary of protection that Microsoft are doing at the network level and, you know, the DDoS level and all of that stuff. But still, it's your responsibility. You don't want to be getting into a situation where you get a piece of malware on your virtual machine and then it spreads east-west, which is, you know, sort of the proliferation within the sort of virtual estate. North-west traffic is, you know, historically that's what an enterprise used to protect for, right? That was north-south traffic, which is basically in and out of your data center or your server room. Nowadays, with, you know, the sort of explosion of virtualization, it isn't just about north-west traffic, right? It's not just what's coming in and out, it's what's going east and west, which is to other virtual machines on other physical hosts within the same data center. So, you know, so it's equally, if not more important, to, you know, make sure that you patch things appropriately. Yeah.
The first time you spin up, let's say, the SQL Server image,
yep.
What the question that was just asked, we're pretty confident that it is
pretty much up to date.
Yeah.
Yeah, it depends on the image, right? I mean, if you deploy a Windows Server 2008 machine,
up to date after that.
Right. I mean, but the first thing I do, you know, once I've got the thing provisioned, before I even join it to the domain or get it talking to anything on my internal network, patch it, right? Make sure that that's done. Maybe I want to put an antivirus client on there, update that, you know. So the same sort of principles apply. Just because it's in the cloud, it's still your responsibility, right? And it's an important takeaway, really, because, you know, Microsoft are all about this is a shared responsibility model, right? It's not just up to them. It's not just up to you. You know, everyone's sort of responsible for the services that you provision. There's two ways you can deploy a SQL server with bring your own license, or you can provision it with the license included, and then that's basically built into the monthly cost. Yeah. And the good thing about that is if you know, let's say you want the SQL, you need SQL to be running at, you know, I don't know, you need it running on an 8-core machine with 56 gig of RAM for a few hours, you know, every twice a month. So you can scale it up to that for whatever period you want, and then you can scale it back down to, next to nothing, right? You can put it back onto a V1 machine, a D1 machine, and it's going to cost you a lot less for the remainder of the month. So yeah, all of those, if you deploy it with the bring your own license, you're responsible for, it will ask you for your license key, right? But if you want it built in, you don't have a license, then yeah, you can just provision it right out of the box. And we'll get to that later on. We're going to provision one, and you'll see how swift it is. So I'm going to fly through these VM series because there are a lot. I'm going to keep it pretty high level yet. So if you provision a virtual machine, the question was, is backup automatic when you provision a virtual machine? Well, not necessarily. We're going to get to backup a bit later. So I'm not trying to fob you off with that question. It's a really good one. Backup is going to be a whole topic towards the end of the afternoon. There's a number of ways that you can protect stuff, but to answer your question, if you deploy a virtual machine straight out of the box, no, it's not going to get backed up for you. It's going to sit on... So you only get an SLA from Microsoft on a virtual machine if you put it into an availability set. So if you deploy one VM, no SLA. Okay. If you deploy two and you put them in an availability set, then you have an SLA on that machine. So if they patch it or they lose that rack, you have an SLA that your service is still going to run because it's in an availability set, which means the other VM as part of that service is on another physical piece of kit somewhere. But we'll get to that. So the A-series VMs, this is the cheapo stuff, right? It doesn't mean that they're not high performance, because if you get down to the A8s and the A9s, those are pretty high performance machines, but these are generally what you would use for doing, dev test stuff. The general purpose machines, they can have a high amount of memory, and of course, they were the first to be offered. The D series, they have a 60% faster CPU. Maximum memory you're going to get is 112 gig. They have local SSD storage, and they're designed to run apps that demand higher compute and the temporary SSD performance. The DS, oh yeah, you are seeing this. I thought you were seeing a different screen. So there was an introduction of the S after the D, and also there's the G series and then the GS as well. Basically, the S sort of indicates that they can use premium storage. Premium storage is solid state disks. So D series cannot, but a DS series, you can attach premium storage to it. So if you need that sort of level of performance to where you've got an increase in IOPS, then go with the S series and the SSDs, right? Because then you're not restricted to regular spinning disks. Again, this is just a brief overview. A DS14, you've got 16 cores, 112 gig of memory, and with that comes 50,000 IOPS, right? So pretty remarkable performance. DV2, that's a follow-up to the original D. So these are version 2 of the Ds. So these, again, they're not with SSD because, they're not the DS. But they're a newer generation of processor, which is 35% faster than the D series version 1s. But it has basically the same memory and disk configuration as the D series. It's just that they've got a faster processor. The F series, these are for demanding workloads where you might not need as much memory or a local SSD, for example. So it might be a gaming server or a web server. You don't need premium storage for a web server, but you might want a faster CPU. So they're lower price per hour, and you get the best value in price performance. Compared to the compute unit. So they're really trying to sort of give you some options to where you don't need to buy a G series that's going to come with a massive amount of IOPS just because you need a machine that's got high CPU resource, right? The G, and again the GS, so the GS is with the SSD performance. This is the most memory and runs on hosts which have the Xeon E5 V3 processors. You can get up to 32 cores and a maximum of 448 gig of RAM for you power-hungry developers. And again, this is just an overview of what you could get. You know, a GS5 is 32 core, 448 gig of RAM. You can have a maximum of 64 disks, right, which is a lot. And that's going to give you like 80,000 IOPS. So, you know, there's no generally no restriction on power. The H series, this is these are the kind of machines that I spin up at weekend when I want to do, you know, molecular modeling and fluid dynamic computations. 8 and 16 core VMs built on the Haswell processor. Again, pretty amazing power. And then the N series, this is the last one I'm going to talk about. It's in preview at the moment, so it's not generally available. But these are basically for, they have the exceptional graphic capabilities, right? So they've got this, the NVIDIA GPU cards designed for, you know, VDI solutions, for example, OpenGL and DirectX frameworks. Again, you know, intensive network operations, algorithm crunching, OpenCL-based simulations, that kind of thing.
So if Netflix decided to move, that's where they'd go?
Probably, yeah. Yep. Yeah, this is just basically an overview. You know, it's showing, you know, from an A1 there, it's 1 core, 1.75 gig of RAM. It's not going to cost you very much money. You know, through the D and the G series, it's basically just showing you what the different sort of levels of resources are on each of those series of machines. So a lot to choose from. You know, and it's kind of important to figure out what you need at the start, but not so much, right? Because changing the sizes of any of these, takes minutes, right? If you want to go from a D12 back down to a D2, just click a few buttons and, you know, wait 5 minutes and you're done. So there's something called VM scale sets, right? So you can basically say, right, these are my metrics, and when the CPU gets to 80%, for example, spin up another machine, and it'll do that automatically. You don't even need to pre-provision it, right? It'll just say, okay, it gets to 80%, add another machine to this service, and it just does it under the covers. And the same if it wants to scale it back down. So the process is still running, it's sort of balanced out across other machines. But then this is all about how you architect it too, right? If you put something on one machine and you max the CPU out, it's not going to automatically do it without having some instruction on how to do it, right? Or what to do thereafter. So, but if you're running just one machine and you see that, hey, I need, you know, I'm hitting the CPU core, you go into the portal and say, you know, make this a D4, it'll just, yeah, it will reboot the server, but it's pretty instant. So, storage. I know Alonso spoke a little bit about storage, so I'm not going to bang on too much about it. Blobs are where, you know, sort of the virtual hard disk image files are stored, and that's primarily what I want to talk about, because tables and queues not really of interest to me. I'm not really a DBA or anything. So the benefits of Azure storage, again, I think Alonso touched on most of this, but massively scalable. You can store and process hundreds of terabytes. You only pay for the amount of data stored. Now, that's not entirely true if we're talking about premium storage. Only standard, so blob storage, yes, but if you were to, let's say, provision a SQL server that has 10 1 terabyte premium storage disks attached to it, so 10 terabytes of available storage, you're going to pay for that 10 terabytes on premium storage, right? If you provision a SQL Server with 10 terabytes of standard storage, you don't pay unless you're actually using it. So if your database is 500 gig and you've got 10 terabytes of standard storage allocated to that server, you're only going to pay for 500 gig of standard storage, right? But if you assign premium disks, you're going to pay for it. So it's an important difference there. So it's elastic, of course. Scale up and scale the application storage requirements as needed. Cool thing is that you've got this auto partitioning system. It'll automatically load balance your data based on traffic coming in. Of course, it's accessible from anywhere in the world, tablet device, desktop, whatever. And then the premium storage we spoke about. Low latency, high performance for I/O intensive workloads. SQL Server database being a prime candidate for premium storage. This is a very basic overview, although I do love these graphics. It's basically how a virtual machine uses the storage architecture. So you have your Azure blob. The VM uses a VHD, which is that C drive on the left. You can have disk caching enabled, which is caching at the storage account. The D drive on some of those, on the premium storage machines, you get a temporary D drive, which is actually an SSD that you don't really pay for. It's kind of included in the price. But the important thing to realize is that it's temporary, right? So if you've got two machines in an availability set, and let's say you're running SQL and you're using SQL mirroring, you can make use of that temporary D drive for your SQL logs, right? Just on the understanding that if that VM gets moved, you're going to lose that D drive. But that's okay, right? It's just your temp DB. It doesn't really matter that much. But what you would do to make use of that, you can use PowerShell to sort of put in a startup command and say, I need to check that this D drive exists in case of the machine restarting. And as long as you do that, you're not going to break anything in SQL, right? Because the D drive is going to exist. So you do a check for the D drive, and then sometimes that disk is, half a terabyte of SSD storage. You're getting it for nothing. So there's some good tricks to use for that. Yes. Well, the C is just a file, right? It's a virtual hard disk file. So it's stored in the blob storage. The disk caching, you might not even use the cache because, let's say a domain controller, right? You don't want to have caching on the database, which is your Active Directory domain database, right? Same with SQL. You would want to sort of disable the host caching. So, but for an operating system, where it can cache, it's not really changing that much. So it uses the caching capabilities for performance reasons. And then if you provision a new disk, it would sit in your blob storage account as a separate VHD file. So when you shut that virtual machine down, you can take that, basically that C drive, which is your operating system disk. It's just a file that's sitting in your blob storage, right? You can copy that file to another blob store, another region. You can provision a VM off that virtual hard disk. So it's sort of encapsulated within one file. And you know what I mean? So
it persists. Okay.
Yeah. Oh yeah, it persists, yeah.
So you can fire up another one and clone it.
Exactly. The D drive is non-persistent though. That's
right.
The point I was trying to make. In the old days, right, if you deployed Windows to a machine that was a 2-core machine, and then you tried to you took a sysprepped image of it and you put it on a 4-core machine, you get a blue screen. So no, I haven't seen that happen. That would kind of break the whole model of being able to scale up and scale down. But if you have an application that is very dependent on talking to the hardware, right? Yeah. But personally, I haven't seen that. So it's again, you want to try and provision best you can at the start for what you're trying to achieve. But if historically you needed to know like all those compute demand patterns, you needed to know what was the peak and provision accordingly, right? And now that idea is out the window really. The idea is now that you go up and down as you need it. But no, I think unless you have something that really talks directly to, well, there's nothing physical about it now, right? Premium storage, we already talked about that quite a bit, but if you want to deploy SQL, for example, you want the best performance, so use premium storage. Keep the storage account and the server VM in the same region. I mean, that's kind of common sense, right? You don't want your storage living in East Coast and then the VMs on the West Coast. That would just be ludicrous. Geo-redundant storage, well, it's not possible on premium storage anyway. It's only local replicated. And you want to use a minimum of 2 premium storage disks, one for your log files, one for data files. And if you're talking about a huge SQL database anyway, disk provisioning is something that you need to pay attention to, because each one of these disks, there's a P10, P20, P30. They all have different sizes and they also have different IOP performances. So you could get away with 5 P10s, or you might want to deploy 2 P20s. It all depends on cost and IOPS basically. Again, don't enable caching on the disk hosting the log file, but you do want to enable the caching on the disk hosting the data files and the tempdb. You can stripe across multiple disks to get your increase in I/O throughput, just like you could with traditional sort of SAN implementations, and use the correct allocation size. Oops, well done. Again, yeah, we spoke about this a little bit. So your virtual hard disk, right? Let's say you've got on-premise Hyper-V or VMware ESX implementation. You've got virtual machines running. You can take that VHD file, basically just lift and shift it, shut your VM down, take that virtual hard disk, copy it up to Azure into your blob storage. Create a disk or image, and then, oops, sorry, too fast. And then provision your virtual machine from that image or from that disk via, you can script it, you can do it from the portal. Basically, in the gallery, you have the option of uploading your own images as well as those that are available in the marketplace. And once your image exists up there, or the flat disk file, you can tell the VM to use that as its virtual hard disk. So that's bringing your own server off premise to the cloud fairly quickly. Same thing there, really. Image mobility. Yes, no problem. Yeah. I think we're getting close. My throat's hurting. Imaging VMs in the cloud. Same thing, right? If you're already running a VM in the cloud, the same principle applies. You're still using a base virtual hard disk file. You can customize it, install whatever program you want on there, generalize it using sysprep, shut the VM down. Then you've just got a file in the blob store, and from that file you can provision, however many virtual machines you want from that one image. Right? It's really straightforward.